Question 1. Part A. Which of these canals has the least length? So which of these is the smallest number? 58.3. But answer the question. It says which of these canals, not how long is it. So your answer has to be Manchester. Now part B, write 77.1 correct to the nearest 10. So we're going up in 10. So 60, 70, 80. So that's nearest 80. And then part C, the Kiel Canal was opened in June 20th, 1895. How many years old was the canal on June the 20th, 2000? So we've got to do 2000, take away 1895 on your calculator, and that's 105 years. Question 2, part A. Now, given this is a calculator paper, I think the easiest way to put these in order is to turn each of them into a decimal, an approximate decimal. You don't have to be exact. So on your calculator, do 1 over 6 and 1 over 10, and 3 over 4 and 1 over 2, giving you these 4 decimals. Now just make sure you can then just compare these easily. So that's the smallest one, second smallest, third smallest, fourth smallest. And but do make sure that your final answers, you list it in terms of the fractions, not your decimals, which of course were just your working. Write 1/4 as a decimal. Again, you can use your calculator if you're not sure. 0.25. Part C, write a fifth as a percentage. Well, percentage means out of 100. So 1 out of 5 is the same as, say, 2 out of 10 or 10 out of 50. But however you do it, you need to scale it up to being a fraction out of 100. So given it was 2 out of 10, that would be 20 out of 100. Out of 100, that's what we wanted as it's a percentage. 20 over 100 is 20%. Now part D, again, you can do this on your calculator if you want to be double sure, but if you want to do it without a calculator, a whole is 8/8. 8/8 take away 5/8, just subtract the numbers on top, the numerators. 8 take away 5 is 3, so that's 3/8. Question 3, part A. We just need to measure that with a ruler. So the measurement from O to P is 3.5 centimeters. Now for part B, we're told the point Q is 2 centimeters from O, and the angle between OP and OQ is a right angle, is 90 degrees. So what we need to do, we just need to make sure we've got a 90-degree angle here. So just measure 90 degrees with a protractor. And then we need to be 2 centimeters away from O. So just go 2 centimeters up that 90-degree line that you've marked. So Q will be there. Question 4, part A. Write down the volume of fresh water made per day from sea in Saudi Arabia in 2015. So we've just got to take the reading for this first column here. Now we can see that there are 5 lines going between 9 and 10, so each one must be 0.2, so that's 9.2. And part B, more fresh water was made per day from sea water in the UAE in 2015 than was made per day from seawater in Spain. So we need to compare the UAE total with the Spanish total and see what the difference is. Now the UAE total, with 2 lines above the 8, so that's 8.4, and the Spanish total is 1 line before the 4, so that's 3.8. 8.4 take away 3.8 is 4.6. And then finally for part C, we need to pop in the bar for Qatar in 2015 that had 1.7. So we need to go up 3.5 square lines above the 1. So it's hard to actually make that clear on here, but I've gone 3.5. That pink line's supposedly halfway between the 3rd and the 4th line, giving us the Qatar total over here. Question 5, part A. Which number in the list is a multiple of both 6 and 9? So think about your 6 times table and your 9 times table, and both of them we get to 18. Part B, 2 numbers in the list are factors of 90. Now remember, factors are smaller numbers. Factors are whole numbers which multiplied by another factor will give you 90. So 15 is a factor because 15 times 6 would give you 90. and 18 is also a factor because 18 times 5 would give you 90. So 5 and 6 are also factors, but they're obviously not in the list. Part C, write down two numbers in the list that have a sum that is a prime number, so that when you add them together you get a prime number. For example, 15 and 16 gives you 31. 31 is prime because the only factors of 31 are 1 and itself, 1 and 31. There are no other factors. 31 is prime. So 15 and 16 as an example of a correct answer. Question 6, part A. Write down the coordinates of point B. Well, that's 6 along the corridor, 2 up the stairs, so 6, 2. Now part B, on the grid mark with a cross X the point with coordinate 4 minus 1 and label this point D. So 4 minus 1 is 4 along the corridor to the right and then 1 down the stairs, so D is there. Part C, what type of triangle is triangle ABC? Well, ABC has got two sides that are the same length, not 3, so that is an isosceles triangle. Part D, find the coordinates of the midpoint of the line AC. Now A has got the coordinate 2, 2 and C has got the coordinate 4, 7. So we need to go halfway along between those. So you average the x coordinates and you average the y coordinates. So the x coordinate of A is 2 and the x coordinate of C is 4. The average of 2 and 4 is 3. So our x coordinate is 3. Similarly with the y coordinates, so the y coordinate of A is 2, the y coordinate of C is 7, the average of 2 and 7 is 4.5. Now I've worked out that average by adding the two together. 2 add 7 is 9, and then halving that to get my 4.5. Question 7. So we've got 2 adults going on the journey, so 2 lots of 53.5 is 107, and then we've got to work out the price of the children's tickets. Now we're told the cost of a children's ticket is 60% of the cost of the adult ticket. So given it's a calculator paper, it's good if you can work out 60% of £53.50 other than going down the route of a 10% and 6 of those. I mean, that's fine if that's the only way you know how to do it, but 60% is 60 out of 100, which is 0.6. So to work out 60%, you simply need to do 0.6 times 53.5, giving you a child ticket price of €32.10. So we're buying 2 of these, so 2 lots of 32.10 is 64.20. So add together the cost of the 2 adult tickets with the cost of the 2 child tickets, gives us a total cost of the 4 tickets of €171.20. Now he pays with 2 €100 notes, so he pays with 200. 200 take away the cost of the tickets, the 171.20, gives us €28.80. Question 8, part A. So to simplify this, we have to gather up our... Now be careful, it's 5x take away x. So 5x take away x is 4x. And similarly, it's 4y take away y, which is 3y. So 4x plus 3y. Now to solve part B, we start off by subtracting 3 from both sides. So 2t equals 9. Then we divide both sides by 2. So t equals 9 over 2. Now that's fine as a final answer, but you could have given 4.5 or 4.5 instead if you wished. Question 9, part A. So we can see the way the pattern goes, we add to both ends. So to go from pattern number 1 to pattern number 2, we added a black on to either end. Then to go from pattern 2 to pattern 3, we added a white on either end. So to go to pattern number 4, we're just going to add another black on either end. Now part B, find the total number of counters in pattern number 6. So let's try and establish the relationship between the pattern number and the number of counters in the pattern. So pattern number 1, we've got 3 counters. Pattern number 2, we've got 5 counters. Pattern number 3, we've got 7 counters. So we can see that we're going up in 2s each time. Pattern number 4, we had 9. So pattern number 5 is going to have 11. Pattern number 6 is going to have 13. So there are 13 counters in pattern number 6. So work out the number of black counters in pattern number 14. So again, we need to try and establish the relationship between the pattern number and the number of black counters. So pattern number 1 has got one black counter. Pattern number 2 has got 3 black counters, and pattern number 3 has also got 3 black counters. Then the next pattern's got 5 black counters, and the next one has 5. So we can see the pattern. We start off with a 1, and then it's 3 3, then 5 5, then 7 7, and then 9 9. So basically, if the pattern number is even, we just add 1 to it. So when the pattern number is even, say for example 6, we added 1 to it to go and get that there were 7 black counters. When the pattern number was 2, we added 1 to get the 3. So pattern number 14 is even, so we simply just add 1 to this. 14 add 1 gives us 15. Part D, work out the total number of counters in pattern number 50. Now for this, I think it's easier to use the nth term expression. So remember how we do this. Because we're going up in 2s, we start off, the first term in the expression is 2n. Had we been going up in 3s, it would have been 3n. But we then need to do this adjustment. Now the adjustment is the number that would be the theoretical 0th term. So imagine a number pushed to the front of the queue and became term number 0. What would that number be? Now term number 1 is 3, term number 2 is 5, and so on. So how do we go from right to left? We are subtracting 2 each time, so our 0th term would be plus 1. So our nth term expression is 2n plus 1. Now this expression allows us to work out any number in the pattern from just knowing what pattern number it is, where it comes in the queue, what position it has. Now we're trying to find out the number of pattern number 50, so that's position number 50 in the queue. So n equals 50. 2 lots of 50 is 100. Add on the 1, we get 101. Question 10. So there are 7 red beads, 11 green, so there must be 2 yellow in order to get 20 beads in total. Part A, write down the probability that she takes a red bead. Well, that's 7 out of 20. So we write that as a fraction, 7 out of 20. Now part B, find the probability that she takes a red bead or a yellow bead. Well, we've got 7 red beads, 2 yellow beads, so that's 9 in total. So the probability of choosing one or the other is 9 out of 20. Now there are 26 counters in a bag. 5 of the counters are pink, 10 of them are blue, and the rest are white. So to start off with, we've got 5 pink plus 10 blue plus 11 white. That gives us a total of 26. Now what we're told, Jan puts some more pink counters in the bag, so that they're going to go up. So I'm going to say, let's just say we're putting in an extra X number of counters. She then takes some blue counters out of the bag. Okay. After she has done this, there are still 26 counters in the bag. So what that's telling us, if given there's still 26 in the bag, however many she puts into the, however many extra pink counters she adds, she must be taking away the same number of blue counters. So we can think of that as being plus X and minus X. Now we're told Jan then takes at random a counter from the bag, and the probability she takes a pink counter is a half. Now for the probability to be pink being a half, she's got to end up having 13 pink counters, because 13 out of the 26 would give us a probability of a half. So we've got to go from having 5 pink counters up to 13 pink counters, so she's got to be adding 8 pink counters. And like we were saying before, if she's adding 8 pink counters, she's taking away 8 blue counters. So how many blue counters has she now got? 10 take away 8 is 2. So what is the probability she takes a blue counter? Well, that's going to be 2 out of 26. Because there's 2 blue, 26 counters in total. Now you could simplify this to 1 over 13 if you wanted, but you didn't need to get full marks. Question 11. So part A, on the grid, reflect triangle S in the line with equation x equals 5. So just be careful with this mirror line. The line x equals 5 is a vertical line through the number 5, because all the x coordinates of all the points on this line would be 5. For example, 5, 0 or 5, 1 or 5, 2 or 5, 3. So that's a very easy mistake to make. The line x equals 5 is not parallel to the x-axis. So once we've got the mirror line in place, it's easy enough to reflect the shape. If we take this point, for example, it's 1 away from the mirror line, so it's 1 away after the reflection. This point here, 2 away, so 2 away. So this reflected shape is here, which I've labelled T as requested. Now on the grid, reflect triangle T in the line with equation x equals 2. So here's x equaling 2. Reflect T, I get this shape U here. Now describe for part C fully the single transformation that maps triangle S onto triangle U. So getting S onto U, well, this is just a shift. We can see this is just a shift to the left. It's sort of exactly the same shape. It's still got its right angle down at the bottom left. It's still got the 1 along the bottom and 2 up. So it's just shifted to the left. Now, how do we describe this shift? This is called a translation. And then how many to the left has it gone? Well, let's just take a point. Say, for example, the bottom left-hand corner. Well, that's gone 1, 2, 3, 4, 5, 6. So that's gone 6 to the left and nothing up or down. So we use a vector to say this. So the top number gives us the shift left or right. As we're going left, that's minus 6. So 6 to the left, nothing up or down. So translation by minus 6, 0. Question 12. So the 4 songs has got to add up to 20 minutes, and these are the times of 3 of these songs. So what I've done, I started off by adding up the seconds. So 16, add 28, add 35 is 79 seconds. And I've added up the minutes. 6 add 4 is 4 is 14 minutes. So we've got 14 minutes, 79 seconds. Now obviously 79 seconds is over a minute, because the minute's got 60 seconds. So 79 seconds is 1 minute, 19 seconds. So onto my 14 minutes, I can add 1 minute and 19 seconds. So 14 minutes, 79 seconds is the same thing as 15 minutes, 19 seconds. Now I want to see how long it is from 15 minutes, 19 seconds all the way up to 20 minutes. So let's start off by rounding up to the next whole minute. So another 41 seconds would take me to 16 minutes, because 19 and 41 is 60. So once I've got to 16 minutes, I've then got another 4 minutes to get to my 20 minutes. So how long is this 4th song? It's 4 minutes and 41 seconds. Question 13, part A. Now you may have been shown how to use your calculator using the table function to complete the table. So you would just make sure you start at -2, finish at +4 and go up in steps of 1. So that would allow you to fill in these values. If you're not familiar and knowing how to do that, it's easy enough just to fill in just by working them each out. So remember, each time you're just taking the x value, substituting it into the function to get the y value. So for example, when x is 0, pop 0 into here, 2 lots of 0 is 0, 0 take away 5 is minus 5, hence the minus 5. When x is 1, 2 lots of 1 is 2, 2 take away 5 is the minus 3, and so on. Now you can quite quickly see the pattern. We're just going up by 2 as we go left to right. So once you're comfortable with the pattern, you can just double check your answers. So we just make sure that you're going up by 2 each time. Now for part B, just plot these points in the graph and make sure you fill in the straight line going all the way from minus 2 up to plus 4. Now part C, mark with a cross X a point on the grid that is coordinates satisfying both of these. So first of all, we've got to have points where X is less than 2. So start off by drawing on the graph the line where X equals 2, which is down here. Remember, it's the vertical line going through 2. So we need our point to be to the left, our point P to be to the left of that line, because it's got to be less than 2. And then we've then got to find a point where y is greater than 2x minus 5. So y is greater than 2x minus 5. So the y coordinate's got to be greater, so we've got to be above that line. So it's got to be to the left of the purple line, above the blue line. I'm thinking, for example, 0, 0. Now it's a good idea to just double check that you've got your point correct. So just think about 0, 0. Is the x coordinate and 0, 0 less than 2? Yes, it is. 0 is less than 2. And is the y value greater than 2 lots of the x value minus 5? Well, 2 lots of 0 is 0. 0 take away 5 is minus 5. So is your y value 0 greater than minus 5? Yes, it is. So that's sort of like a good little double check to make sure you've gone right. You've got your correct answer. So P, of course, didn't have to be at 0, 0. It could be any of these coordinates over here, which is to the left of the purple line and above the blue line. Question 14, part A. So just pop this into your calculator to get 48. And part B, 11 to the power of 4. So make sure you use the button which has got the X and the little square in the corner. So that's normally about halfway along near the top of your calculator. So the X with the little square, the 11 is the X, and the 4 would be the little square, giving you 14,641. Question 15. So the first thing to take on board here is 1 litre is 1,000 centimetres cubed. So you've just got to learn that. So we need 9 litres of water for each fish. So 9 litres is 9,000 centimetres cubed per fish. So given we want to keep 20 fish, it's going to be 20 lots of 9,000, which is 180,000 centimetres cubed for the 20 fish. So we're going to need to have a total volume of 180,000. Now how do you work out the volume of water? You do base, so 45 times the depth times 80 times the height. So 45 times 80 times the height is going to give us our volume. So working backwards, if we do 180,000 divided by 3,600, that would tell us that we need to have a depth of 50 centimetres, because 45 times 80 times 50 gives us a volume of 180,000, and that's what we needed for the 20 fish. So what is the minimum depth of water? It's 50 centimetres. Question 16. So we're going to focus on the left hand side, work out what this is, and show that it's what we've got on the right hand side. So we're going to work out 1 2/3, add 2 3/4. So start off by making them top heavy fractions, improper fractions. So 1 2/3 is 5/3, because 1 times 3 is 3, and add the 2 is 5. And 2 3/4 is 11/4, because 2 4s are 8, add the 3 to get the 11. Now to add fractions, we need to have a common denominator. We need the number on the bottom to be the same. So what do 3 and 4 both go into? They both go into 12. 3 4s are 12. So let's make 12 our common denominator. So how do I convert 5 over 3 into something over 12? Well, I multiply by 4, because 3 4s are 12. So to keep the fraction unchanged, I've got to also multiply the numerator, the top number, by 4. 5 fours are 20. So 5 over 3 is the same thing as 20 over 12. Moving on to the 11 over 4, we want to turn this into something over 12. 4 times what gives us 12? 4 threes are 12. So we also multiply the 11 by 3. 11 threes are 33. So we now have equivalent fractions, which we can then add the numerators together. 20 add 33 is 53. So 53 over 12. Be careful not to add the 12s together. Think about it. 1/3 and 1/3 is 2/3. So do not add the denominators together. Now once we got 53 over 12, we just changed this improper fraction into a mixed number. How many wholes can we get out of this? Dealing in twelfths, well, we can get 4 wholes out of it, because 4 12s are 48. That leaves us with 5 bits left over, so 4 and 5 12s as required. Question 17. So we're told that the ratio of girls to boys is 3 to 1, and there are 60 children in the club. So let's go and split these 60 children in the ratio of 3 to 1. Now 3 to 1 gives us 4 shares in total, but we've got 60 children. So how do we scale up 4 to be 60? Well, we multiply by 15, because 60 divided by 4 is 15. So we're going to have to multiply these ratios by 15. 3 times 15 is 45, and 1 times 15 is 15. So 45 to 15 is following the ratio 3 to 1, with 45 being 3 times bigger than 15. But 45 add 15 is our 60 children. Now we're told that 3/5 of the girls play a musical instrument. So we need 3/5 of the 45. So we can just simply, using our calculator, do 3/5 of 45, which is 27. We're also told 4/5 of the boys play a musical instrument. So we need 4/5 of the 15 boys. 4/5 times 15 is 12. So 27 girls play instruments, 12 boys, so that's 39 children in total play instruments. We're asked what fraction of the 60 children play a musical instrument, so that's 39 out of 60, which is fine to leave that, but if you've wanted to simplify it, you can divide top and bottom by 3 to get 13 out of 20, but 39 over 60 would give you full marks, because the question doesn't ask you to simplify the fraction. Question 18. Now we're being asked to work out the length of PQ. Now to do this, we're going to need to know something else about the triangle PQS. So if we can work out what QS is, then we can work out what PQ is using Pythagoras, because we've got a right angle triangle, side, side, find a side. So how can we work out what QS is? Well, we can work out QS, because QS is part of the triangle QSR. So we can go and work out what QS is by looking at the triangle on the right, and then use that information to work out what QP is. So how do we work out what QS is looking at the triangle on the right? Well, it's side, side, find a side, and we're trying to work out one of the shorter sides. So this is going to be a taking away Pythagoras. So QS squared equals 14 squared, take away 10 squared, which is 96. So QS is the square root of 96. Now that we know the length of QS, we can work out what PQ is. But on this occasion, it's going to be an adding Pythagoras, because PQ is the hypotenuse, the longer side. So PQ squared equals 5 squared plus the square root of 96 squared. That's 25 plus 96, which is 121. So PQ is the square root of 121, which is 11. Question 19. So let's just go and write these down as a list, just to help us gather our thoughts. So we've got A, then B, then 40. Now we're told that the range of the 4 numbers is 14. Now the range is the biggest number take away the smallest number. So 40 take away A is going to be our range, which is 14. So A must be 26. Now we now know that A is 26. Now we're now told that the median of the four numbers is 30. Now how do you work out the median? Well, the median is the middle number. Now when you've got an even number of numbers, obviously there isn't an exact number in the middle. So you median, you work out the mean average of the two middle numbers. So we know that the mean average of A plus B, the two middle numbers, has got to be 30. So averaging A plus B over 2 gives us 30, but we've just worked out that A is 26. So we know that so A is 26, so 26 plus B over 2 equals 30. So why don't we just choose to multiply both sides by 2? So A plus B equals 60, just to get rid of this dividing by 2. But we've just worked out that A is 26. So what must B be? Well, B must be 60, take away 26, which is 34. Question 20. So we're told that the train takes 8 minutes to travel a distance of 30.5 kilometers. So 8 minutes, how long is 8 minutes? Well, 8 minutes is 8/60th of an hour. So that's 2/15 of an hour. Right, now how do you work out speed? Well, speed is distance divided by time. We're trying to work it out in kilometers per hour. So we need the distance in kilometers and we need the time in hours. Now the distance is 30.5 kilometers, and we've just worked out that the time in hours is 2/15. So we do 30.5 divided by 2/15, and we just do this on a calculator, gives us an average speed of 228.75 kilometers per hour. So the key bit here is make sure you go and divide it by the number of hours. Do not try and use the minutes. And of course 0.08 is not how you go from minutes to hours. Well, a key point here is to pick up these two little dashes here. This is telling us that this is an isosceles angle. So the base angles of the isosceles are equal rather. So we can go and set 3x plus 10 to being equal to x plus 52. We can solve this to work out what x is, and once we know x, we can work out what y is. So we're going to set 3x plus 10 to be equal to x plus 52 because these two angles are equal. Base angles of an isosceles triangle are equal. So here we go. So we've got to solve this. So choose to take away x from both sides. So 2x plus 10 equals 52. Then subtract 10 from both sides. We get 2x equaling 42. Halve this, we get x being 21. Now once we know x is 21, we can work out either of these to work out what these two equal angles are. So substituting the 21 into this, we get 3 lots of 21, and we add 10, we get 73 degrees. And of course you're also going to get 73 degrees if you substitute 21 into this one. So these base angles are 73. Well, angles in a triangle add up to 180 degrees, so y must be 180, take away 73, take away another 73, giving us 34 degrees. Question 22. So, we need to get a scale to use here. Now, what we're saying is we're told that the height of Tower A on the scale model is 90 centimetres. But in real life it is 187 meters. So our 187 meters represents 90 centimeters on the scale. Now we want to know how many centimeters on the scale 147 meters is going to be. So how can we get the same proportions here as we've got here? How do we go from 187 to 147? What do we divide by? Well, if we do 187 divided by 147 on our calculators, we get that we divide by 1.272 ... So if we go and apply the same proportion to the scales, we can say 90 divided by our 1.272 dot 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 gives us 70.748 dot 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 centimeters high for the scale model version of the smaller tower. Giving our answer correct to the nearest centimetre, this is going to be 71 centimetres. Question 23. Now in order to solve this, we're going to need to line up either the x's or the y's. So to get the same number of x's, we could choose to multiply the second equation by 4. That would give us 4 x's in both. Or we could take the first equation and multiply that by 2 to line up the y's by having 4 y's in both. Now what I've chosen to do is to line up the y's. So I've taken my equation number 1 and I've chosen to double everything. So doubling 4x, doubling the 2y and doubling the 9, I get 8x plus 4y equals 18. Now I can now compare this to equation 2 and my y's line up. Now in order to eliminate these y's, because the signs of the y's are different, I'm going to choose to add the two equations together. Adding 4y with a minus 4y gives me 0, which is what I want. So I'm adding the two equations together. Now 8x plus x is 9x. 4y plus minus 4y is nothing. That's the whole point. And 18 plus 9 equals 27. So my y's have eliminated. 9x equals 27. Dividing both sides by 9, I get x being 3. Now to work out what y is, I sort of start again really. Now take either of the opening equations. I've taken the top equation, so I'm just starting off with 4x plus 2y equals 9. But I've just worked out that x is 3. So I can substitute 3 into this x value. So 4x is 4 times 3, which is 12. So 12 plus 2y equals 9. Take away 12 from both sides, I get 2y being minus 3. Halve this, I get y being minus 1.5. So x is 3 and y is minus 1.5. Question 24, part A. Now, when you write a number in standard form, the first number's got to be between 1 and 10. So not 480, but 4.8. Now, how do I go from 480 to 4.8? I'm dividing by 100. In other words, I'm dividing by 10 to the power of 2. Now, I don't want to change the number overall. I'm just trying to write it in standard form. So it shouldn't be any bigger or any smaller. It should be the same size number. So if I've already gone and divided by 100, in other words, divided by 10 squared, to compensate for this, I've got to multiply by 10 squared as well. So my 10 to the 9 has got to be multiplied by 10 squared. Now when I multiply, I add the powers. 9 add 2 is 11. So 4.8 times 10 to the 11 is the same thing as 480 times 10 to the power of 9. You could probably pop this into your calculator as well to get that to assist you. Now for part B, write n as a product of powers of its prime factors. Show you're working clearly. Well, if we go and break down the 480, it becomes a 48 and 10, a 6 and an 8. The 10 becomes a 2 and a 5, the 6 breaks down and so on. So this is just the number tree to break the 480 down to 2 to the power of 5 times the 3 times the 5. Now, and we've still got our 10 to the power of 9 to think about. Now 10 to the power of 9 is 2 to the power of 9 times 5 to the power of 9, breaking that down into its prime factors. So our big numbers here are all prime factors now. So now gathering up our prime factors, we've got 2 to the 5 times 2 to the 9, which is 2 to the 14. We've got a 3, and then we've got a 5 to the 1 and a 5 to the 9, which is our 5 to the 10. Now for part C, find the largest factor of n that is an odd number. Now, an odd number times an odd number gives us an odd number. So we need to find the biggest odd number we can get out of this. So that's going to be the 3, so the 3 to the power of 1, and the 5 to the power of 10. So our biggest, our largest factor that is an odd number is 3 to the 1 times 5 to the power of 10, which is 29,296,875. So this is the biggest odd number we can take out of this. Question 25. So let's think of, first of all, working out the area of this semicircle if it was completely filled in. So like this tunnel bit was filled in. Now an area of a circle is pi r squared. So for a semicircle taking up half the space, it's going to be half times pi r squared. So if we think about the whole of the semicircle filled in, this would have a radius of 6. Remember, the radius is half of the diameter. So that would be half times pi times 6 squared, which would be 18 pi. Now let's think about this tunnel area here, because we need to subtract this bit away from it being completely filled in. Now what would be the diameter of this tunnel bit? That would be, we've got 2 here and 2 here, so that would be giving us a diameter of 8, so a radius of 4. So what would be the area of this bit here is going to be half times pi times 4 squared, which is 8 pi. So if we go and take the area as if it was completely filled in, 18 pi, then subtract the white bit in the middle, the 8 pi, that gives us the area of this tunnel shape. 18 pi take away 8 pi is 10 pi. We've been asked to give our answer as a multiple of pi, so we just leave it as 10 pi. Question 26. So we've got 12 boys in total, and we're told that the mean number of coins that the boys have is 5.5. So how many did the boys get in total? Well, they would have got 12 lots of 5.5, which is 66. So they will have got a total of 66 coins, because 66 divided by the 12 would give us their mean number of coins of 5.5. Now we're told that the 8 girls have in total 18 coins. So how many coins do we have in total? We've got the boys total and the girls total. 66 add 18, which is 84. So if that's the total number of coins across the 20 children in total, our mean average of the children is going to be 84 divided by 20, which is 4.2 coins.